Now this is R.D. Sharma solution. We are taking chapter 19, which is indefinite integrals. Now this exercise may be different in your edition. I am taking 19.27. Whole idea is the logic which I am going to tell later. Now in this exercise there are two formulas which we will be using all through. First is e raise ax sin bx dx. The second one is e raise ax cos bx dx. Now let me write it so that it gets embedded into your mind. And there are certain analogy also, similarity also that you will find here while I am writing. So integration of e raise ax sin bx and integration of e raise ax cos bx. The similarity first is that first term remains the same. That is e raise ax divided by a square plus b square in both the terms. So e raise ax a square plus b square, just write it here. They both will be found in both of the equations. Now inside this, of course, we are dealing with indefinite integrals, so we ought to have a constant of integration. Now when we have e raise ax sin bx, just take a and sin bx. So write a, this a and this sin bx. So a sin bx. In the same way, we have a cos bx here. Because it is e raise ax cos bx, take an a and then cos bx. In sin, there will be a negative sign. In cos, it will be a positive sign. Now you just change sin to cos, that is sin bx is there, so make it cos bx. And in the second equation, cos bx will be sin bx. But it will be followed by b, means in both these, followed by a b in front and b along with x. So b cos bx, b sin bx, b cos bx, b sin bx. Alright, I tried to make this fed into your mind. But it's better that when we give a proof, then the whole intricacy will be revealed to you. The e raise ax cos bx is actually your question number 1. So we are going to solve this, but in the questions. For that, for the beginning, e raise ax sin bx, I am going to give you the proof. So we are dealing with e raise ax sin bx. Let's call it as an I, because this is our original integration. And please remember, this is going to be coming again, means we will be revisiting again. Now this e raise ax sin bx, whichever you want, you can take as the first function and second function, because the result is going to be the same. Let's take e raise ax as the first function and sin bx as the second function. So the formula of uv dx is known to you. We start with a u, then integrate v, then minus. Then when we differentiate the first function, that is d by dx of u is done, then the integration of this v dx will be done. So integration of v dx. And once this is done, then we have to multiply them, and again a final integration will be done. So we are going to apply this formula here. You can take uv either of them. It's up to you. I am taking e raise ax as the first function, but when I am going to tell you e raise ax cos bx, then you'll see I will just switch the first function and second function. So e raise ax comes outside, sin bx is integrated, minus, then differentiation of the first function which is e raise ax, then the integration of sin bx dx. Once this is done, then we will integrate all the content on the right hand side. So e raise ax sin bx is minus cos bx, and then bx will be differentiated, it will come as b, and that will be put in the denominator, minus. Now d by dx of e raise ax, again e raise ax will come, then differentiation for ax will also be done, so a will also come. Sin bx dx we have already done, it's negative cos bx by b. So just write this cos bx by b, and negative you can just make this negative in front as positive. Negative becomes positive. So what we will do here, we will take this a and b, which are actually the constants, in front. Means it will be prior to integration sign. And this e raise x cos bx, we will call it as some integral, say I1. So I am doing it separately just to reduce the clumsiness. So e raise ax cos bx, we are integrating it. See, this is the second function I am talking about, which we will be dealing in the question number 1. But here, e raise x cos bx, we'll apply the formula now. So it's e raise ax, again same thing, cos bx minus integration of, now first the differentiation of e raise ax will be done, and then the integration of cos bx, and this whole will be again integrated with respect to dx. So e raise ax will come, cos bx is simply sin bx, and then bx will be differentiated, b will come, it will go in the denominator, minus integration d by dx of e raise ax will be e raise ax only, then a will also come after the differentiation of ax. Cos bx we have already done, it is sin bx by b. Now we have to integrate this again, the second part. Now what do you see here? You will say that this will be never ending process. You will integrate again, cos will come, e raise ax, cos bx will come. Again you have to do this will be a round robin thing. No, you will just see, if you take this, let me write e raise x sin bx divided by b. But the second term, if you take a by b outside the integral, what will remain inside? E raise ax sin bx. But to our utter surprise, this is already what we have started. Means this is what the integral we have started with. So you don't have to integrate it again and again. You just have to write I in front of that. So e raise ax sin bx divided by b minus a by b, and this particular thing is I only. Alright. So this I1 I told you. So we started with this one, I1. And we came to this one, that is I1 is equal to this expression which you see on the right. So let's proceed the initial one, negative e raise ax cos bx by b plus a by b. Now I am bringing this in, which I just called as I1 at my discretion. So e raise ax sin bx by b minus a by b, I is already there. So let me write this again, e raise ax cos bx divided by b. Now multiplying a by b inside. So this will be a e raise ax sin bx, and this b and b will become b square. Now the second term will be multiplied, a by b into a by b will be a square b square, I, and I remains here on the left. Now I am taking this, the rightmost thing, to the left hand side. So when I take this on the left hand side, it will be I plus a square by b square into I plus a square by b square into I. So you can take I common, and this will be 1 plus a square by b square. And this will give you what? LCM take, just multiply this b square plus a square by b square. So a square plus b square by b square into I will come. So the left hand side I have done it here. I have taken this on the left hand side. So let me write the final result here of the left hand side. A square plus b square by b square into I. And on the right, I am just swapping these two terms, because e raise ax is already common. So you can take e raise ax outside. Now I am swapping these two terms, sin bx first and negative cos bx outside, just to show that this matches to what I have told you earlier. Okay. So e raise ax we have taken common. Sin bx I am writing first along with an a. So a sin bx by b square is already there. Now I am writing the first term which contains a negative. So you have a negative cos bx divided by b. Now why I did this? Because we can take the LCM here. When we take the LCM will be b square. So I am showing it to you here because it's getting very clumsy. So I am going to show you here. B square, when you take LCM, b square is also already there, so you don't have to do anything. You can just write a sin bx. And since b square is not there, only b is there, so you have to multiply b to make it as b square. So b cos bx will come. So the final version is e raise ax, or not final but penultimate. So a sin bx minus b cos bx divided by b square. This I have just done. And you have on the right a square plus b square by b square into I. So this b square get cancelled. A square plus b square you can bring it on the right. A square b square you can bring it here. So this is what I am going to tell you or show you, that this is the final result. E raise x is already there. Denominator is a square plus b square. Now you have a sin bx minus b cos bx. And now you can add a constant of integration if you want, because indefinite integrals without a constant of integration will not worth anything. So I is this one. So I hope you got the idea. Now the second one, which is actually the first question. This is also a formula which will be used immensely in this exercise. So e raise ax cos bx is equal to what you see on the right, and I am going to prove it just now. So we have already proved e raise ax sin bx. Now we are dealing with e raise ax cos bx. So you are always told that I late you can follow. Okay, inverse, log, algebraic, trigonometry and exponential. So you can follow this, or you can take any of these as the first function and second function, because in the previous discussion just now, I have taken otherwise. But here you can take in a different way, because this particular integral doesn't follow this I late. Means either of the function can be taken as the first function and second function. Actually, I have tried out, that's why I am telling you. You will see it just now also. And you will see the difference between e raise ax sin bx and e raise ax cos bx. The previous one I took different first and second function. Here I am taking different first function and second function. So I is actually e raise ax cos bx, which we are integrating. and I'm writing it again just to show you that this is going to come again. This will be regenerated while we are actually solving the question. Now let's apply the formula. This I will be equal to, so integration of uv dx, I told you already in the previous one, so I'm going to just apply the formula here. So this is cos bx as the first function, integration of e raise ax, and then the differentiation of the cos bx first function, and then integration of e raise ax, and then with the dx. So we have cos bx, integration of e raise ax will be e raise ax, and then the differentiation of ax will give you a, and that will be kept in the denominator. So you have a in the denominator, minus. Now cos bx will be what? It will be negative sin bx. Remember, you are differentiating here. So minus minus, I'm making it plus here itself. So minus sin bx, cos bx will be negative sin bx, and then bx will also be differentiated. That will give you b. And what about integration of ax? It will be e raise ax by a. So we need to integrate it again. Let me add b also. So this has to be integrated again because it is inside an integral sign. We have e raise ax sin bx. I have taken b by a outside. So let me just complete by writing this e raise ax divided by a, and this is cos bx, I equal to this one. Now let me call this as I1 because I am going to do it separately just to increase the understanding. E raise ax sin bx on the right, I have taken it as I1 at my disposal. So again, you can take any of this as the first function, any of this as the second function. You don't need to follow I late. So I'm taking sin bx as the first function and e raise ax as the second function. So let's start with sin bx now. This is sin bx, integration of e raise x minus integration, then the differentiation of sin bx will give you cos bx, and then since differentiation has been done, b will also come. Integration of e raise x also. So we have sin bx, this will be e raise ax by a minus this differentiation of cos bx has already sin bx has already been done, so we have a b cos bx. So there will be b cos bx. I have left it, just assume that it is there. E raise ax will be e raise x by a. So let me write b also and cos bx also. So cos bx here. Now to our again a surprise, you'll see that from where we have started, we have again come back to the same juncture. That is the first term I am writing like that. But here if you take b by a outside, the inside will be e raise ax cos bx. And what is this? I told you that it is going to be regenerated. It will come again. So this is I only. So let me substitute this as I only. That is e raise ax sin bx divided by a minus b by a. And this integration of e raise ax cos bx will be I. And there is a b by a also. So let's multiply b by a here only just to make it clear and not very clumsy. So b, I'm multiplying now. So b e raise ax sin bx is the numerator, a into a is the denominator, a square. Now again b by a into b by a will be b square by a square with our I. Now I am taking this all and putting it in the original equation. So e raise ax cos bx by a will remain like that, plus b into e raise ax sin bx by a square. I'm just taking this and putting it here. Nothing, no change I'm making it here. Minus b square by a square I. Now this rightmost thing, I am just taking or transferring it to the left hand side. So this will form I plus b square by a square into I equals to what? I 1 plus b square by a square if you take I common. So this will be a square plus b square by a square into I. So left hand side will be now a square plus b square by a square into I. And on the right hand side, e raise ax, let's take common. What will remain inside? Cos bx plus b sin bx. Here it will be a and here it will be a square. Now let's take the LCM. When you take the LCM, it will be a square. So since this already have a square in the denominator, you can just write b sin bx. Here we have only a in the denominator, so in order to make it a square, you have to multiply it with a cos bx. Okay, e raise ax remains here. Now a square plus b square by a square. First thing is you can just cancel this a square and s square in the denominator, and you can bring this a square plus b square on the right. So this integration I will be e raise ax, in the denominator it will be a square plus b square, and followed by a cos bx plus b sin bx. And now you can add a constant of integration, and this is the actually the proof also and solution of the first question as well. This is from where we started, okay? So this is the proof of e raise ax and e raise x, cos x and cos bx and sin bx. Now just need to see it cleaner, and I want you to do it again. I request you to follow this, because all the other questions which are coming up, if you don't understand this e raise ax, cos bx and sin bx integration, it will be very difficult for you to understand the other question. Now this kind of question where we have e raise x sin bx plus c. So we have already dealt with e raise ax sin bx or e raise ax cos bx. Now this addition of constant, what will happen? What will change? So we'll try to prove this and solve this. If you take this I late, you know that this is inverse, log, and then algebraic, trigonometric and exponential. So this t and e, trigonometry will come first, the function will be first, and then exponential will be second. So we'll take this trigonometric as the first function, e raise ax as the second function. Now applying the formula of u into v, that is two function multiplied, how to do the integration of that thing. You already know the formula like this. Start with the u, then integration of v with respect to dx, minus integration of differentiation of first function, then the integration of the second function again with respect to dx, and then we will integrate this again with respect to dx again. So we are applying same thing here now. So we have this sin bx plus c as u, e raise ax as v. So this integration will be applying this formula. How this will be formed? First is sin bx plus c, which is u, and then the integration of v, which is e raise ax, and then integration of du by dx. What is u? Sin bx plus c. So the differentiation will give you what? d by dx of sin bx plus c will be cos bx plus c. That I'll show you just now. Let's complete this integration of ex dx again. So once you do all on the right, you have to integrate it again. So e raise ax will be simply e raise ax, and then the differentiation of ax will be a, that has to be in the denominator. Then sin bx c will remain like that. d by dx of sin bx plus c, it will be cos bx plus c, because we are differentiating. It will be cos bx plus c. Then we have to differentiate bx plus c also. b will come then. Then e raise ax, we have already done that. E raise ax divided by a, and then this has to be integrated again. Now this b and a I am taking in front of integration sign. Now you have to do this in a different step, but you already know that b and a are already there, so I can just show you here that b and a can be taken outside. Now e raise ax into cos bx plus c is in itself a new integration. So let me call it as some I1, and you will see that will be a reincarnation. That means the actual integration from where we started will come again, and this will be going on loop. So we'll stop that loop and I'll show you how. So this e raise ax cos bx, which we assigned as I1, will be integrated in a separate way. Then we'll join it along with that I. So this I is I1 is u as cos bx plus c, v as e raise ax. That is, first function we will take as per I late. First function will be cos bx plus c, second function will be e raise ax. So this will be cos bx plus c, this is the first function. Integration of e to the power ax minus, and then d by dx of cos bx plus c. Then the integration of e raise ax again with respect to dx. And once this is done, we'll again integrate it. So e raise ax will be e raise ax divided by a. Cos bx plus c remains unchanged. Minus d by dx of cos is what? Cos is minus sin x. Differentiation of cos x is minus sin x. So I'll just change the sign, because when it comes as negative cos bx plus c, this negative will become, because we can take this negative outside, it will become positive, and this b I can take outside. Cos bx plus c remains like this inside. Cos will be sin. So let me write sin bx plus c, and this e raise ax will be integrated. So e raise ax divided by a will come, as we have just done here. So I am taking a outside. So the constant which has come, I have just taken it outside the integration sign. But what do you see here? Why I have taken this out, constant outside? So this is, I was saying that there is a reincarnation Sine bx plus c e raised ax is the actual integration, and that has come up again. So this b by a, integration of b sine bx plus c e raised ax will be I. This I1 will be what? E raised ax by a and cos bx plus c plus b by a I. So this I1 has started from here. So we will keep this thing alive, and now this part which we assume to be I1, we will substitute the I1 which we got just now. So we'll replace equation number 3 in equation number 2. So this I has come like this: e raised ax sine bx plus c and divided by a. Then we have, what was I1? I am now replacing I1. So there was b by a, and inside this we'll replace it by I1. So it will be e raised ax cos bx plus c divided by a plus b by a I. Now we'll multiply b by a inside. So e raised ax by a sine bx remains unchanged. Now multiplication will give you b into e raised ax cos bx plus c, and the denominator it will be a square. So the numerator will be like that, but b by a into 1 by a will be b by a square. Then minus b into b will be b square, a into a will be a square, minus b square by a square into I. Now this whole goes on the left here. So it will be I plus b square by a square into I is equal to, now you can take something common from here, and you also have to do the LCM thing. So we'll make it as a one term. For that we'll take a square as the denominator, that is the LCM. So the right hand side a square is already there, so the numerator will only come b into e raised ax into cos bx plus c. Now the first term, because it is a in the denominator, a has to be multiplied in the numerator. So e raised ax sine bx plus c will come. Now the left hand side, which is I plus b square by a square plus I, let me do it here. I am taking I outside, so it will be 1 plus b square by a square. So this I will be a square plus b square by a square, and this is I into. So on the left I will write a square plus b square by a square into I is equal to, now e raised ax can be taken common also. So we have a e raised ax sine bx plus c minus b e raised ax cos bx plus c, and this a square. So you can cancel this a square, and I was suggesting this a square plus b square has to be taken downstairs on the right hand side. So e raised ax can be taken common. So e raised ax I am taking common. A square plus b square can be brought in the denominator, and the inside will be a sine bx plus c and minus b already there cos bx plus c. Alright. So this is an indefinite integral, so you have to add a constant of integration. Okay, this is how this will be solved or proved. Now sometimes you will understand that e raised ax sine bx and e raised ax sine bx plus c are same. They are not. So let me show you the proof also in a printed form so that you can try it by yourself, or you can remember it how to write this if it at all comes in your examination. Cos log x dx. Now there are certain ways in which we can go about it or proceed to solve it. Now you can just do like this, 1 into cos log x. This is one way, and you can apply the isolate rule and you can go about it. But you can see that log x is already there, and since we are doing this exercise, log x and e raised x are quite interrelated. So if you take log x as t, that means e raised power t is x. Let me remind you that log base a b equals to c is nothing but a raised c is equal to b. So same concept here. Now we have assumed something and we have to substitute later also. So let me mark it as 1 and 2 equations. So x equals to e raised t, we need to differentiate it also, because if you're substituting somewhere or assuming, you need to think about all the content in the question, because dx is already there. So dx by dt will be equal to e raised t, dx will be equal to e raised t dt. Now this dx is what? You have to substitute this because everything you have taken in the form of t. So now this equation will be transformed after all this assumption or this substitution. I will be equal to integration of what is cos log x. In place of log x you can write t In place of dx, you have to write e raised t dt. Now e raised t cos t dt, we know the formula directly. That is e raised ax cos bx. If you remember, integration of e raised ax cos bx. Now most of the people will tell you that if you remember this formula, just apply it here. But I will not second it. I will recommend that you solve it in the way integration is done. Because e raised ax cos bx, when you prove it, then the final result will come. And you can just put this a and b, and then you can just solve it using the formula only. But I will encourage you not to use the formula. Use it as the integration is done. So first function is cos t here, second function is e raised t here. We will apply the same result, that is integration of u into v into dx. This u and v are the first function and second function. So I will be equal to cos t integration of e raised t minus integration of differentiation of cos t, then integration of e raised t. So dt will come here, and then dt. So I will come like this. E raised t will be e raised t only. Cos t is unchanged. D by dt of cos t will be minus sin t. So this will become plus sin t inside the integration. E raised t will remain e raised t. Now e raised t sin t. E raised t sin t dt. So this I1, call it as I1 because we will do this I1 separately and then we will replace it. So I1 is a separate thing which we are doing. So this first function will be sin t, second function will be e raised t. This will be sin t, integration of e raised t dt minus integration of d by dt of sin t, integration of e raised t again with respect to dt, and this final will again be integrated. So this is sin t, e raised t will be e raised t only, minus d by dt of sin t will be cos t, and e raised t dt will be e raised t again, and dt. Now why we did this? Because I was initially, when we did some substitution or assumption, we started with this I only. It's e raised t cos t dt. So e raised t sin t will remain like this, minus cos t e raised t will be I. This is your third equation, I1. Now we are replacing this I1 in our I from where we left. So I will be e raised t cos t. This I1 will be taken from equation number 3, that is e raised t sin t minus I. Now this I can be taken on the left hand side. So this I plus I will form 2I. And this will be equal to e raised t cos t e raised. So you can take just e raised t common from here. 2 you can bring downstairs on the right hand side. So cos t plus sin t will come. And this I will be what? Because now you need, because you assume something, so you need to substitute them in at the last. So e raised t was x. Cos, in place of t, you can just write log x. So cos log x plus sin log x, this t again with log x, and plus a constant of integration. This is your final answer. So just having the formula and solving it will not solve the purpose. You have to do it exactly the way it has to be done. And this is the printed version. So if you're writing by yourself or in the examination, you have to do something like this. Now we have e raised 2x cos 3x plus 4. Now many people will say that there is a direct formula in the exercise or in the r.d.sharma or any other book. You can just apply that formula and just write and that is finished. No. If they are saying or you are adopting this, see, e raised ax, and what is a and b? A is 2, b is 3 and c is 4 because it is the form of e raised ax cos bx plus c. So we'll do it in the way it should be done, as integration of two different terms. So we'll apply isolate. Trigonometric function will first, exponential will be second. So u will be cos 3x plus 4, v will be e raised 2x in this case. So integration of u and v dx you already know, and I'll just apply that here. So this I will be, so it will be cos 3x plus 4 and then the integration of e raised 2x dx minus integration of then differentiation of cos 3x plus 4 and then the integration of e raised 2x dx, and then again it has to be integrated again with respect to dx. So e raised 2x will be e raised 2x by 2, cos 3x plus 4 remains like this unchanged, Cos is a negative sign, so minus minus positive, sin 3x plus 4. When you differentiate this, 3 will also come out. So 3 I am bringing outside. E raised to x will be e raised to x divided by 2. So e raised to x you can write, and thus that 2 I am bringing outside. As constant all I am bringing outside. Now e raised to x sin 3x plus 4 is again an integration of this sort only, or this type only. So let us call it as I1. We will integrate this I1 and we'll replace it later. So this I1 is integration of e raised to x sin 3x plus 4, and this has to be integrated. Again isolate will be applied, cos or sine, these are all in trigonometric things. So this sin 3x plus 4 will come first, integration of e raised to x with respect to dx minus integration of d by dx of sin 3x plus 4, and then the integration of e raised to x dx again, and then final integration with respect to dx. So it will be sin 3x plus 4. This will be e raised to x divided by 2 minus d by dx of sin 3x plus 4 will be what? Cos 3x plus 4. Then 3x plus 4 will be differentiated again, 3 will come outside. E raised to x will be again e raised to x by 2, 2 I am bringing outside again. So this is the integration which we called as I1. Now this is what? This is the original equation which we started. Alright. What was I1? I1 is e raised to x divided by 2 sin 3x plus 4 minus 3 by 2, and this is I only. So I am writing I. Now this I1 has to be replaced here because from here we left. I told you we will do I1 separately and then we will shift this I1 into the original equation where we left. So I becomes e raised to x by 2 cos 3x plus 4 plus 3 by 2, and inside this replace I1. So e raised to x by 2 sin 3x plus 4 minus 3 by 2 I. So I will become like this, e raised to x by 2 cos 3x plus 4, and then plus 3 by 2 needs to be multiplied inside. So 3 by 2 to the 4 e raised to x sin 3x plus 4, and 3 by 2 into 3 by 2 will be 9 by 4. So minus 9 by 4 I. Okay, negative 9 by 4 we will shift it on the left hand side and we will add it with I. So I plus 9 by 4 I. This I will come out 1 plus 9 by 4. 4 plus 9 by 4 that will be. So this will be 9 plus 4, that is 13 by 4. So this whole will be 13 by 4 I on the left. So 13 by 4 I is equal to, now you can take e raised to x common, and also you can take the denominator as 4. That means you can take the LCM of these two. Since we have a base as 4 in the numerator, you have to multiply 2 with cos 3x plus 4 because only 2 is in the denominator, and we have taken 4 as the denominator for LCM. And since 4 is already there with the sine term, so it will remain like that. You just have to do that. It will be 3 sin 3x plus 4. Now this 4 you can cancel. You can bring this 13 in the downstairs of the right hand side. So I will become like this, e raised to x divided by 13, 2 cos 3x plus 4 plus 3 sin 3x plus 4, and that's your final answer along with the constant of integration. Now e raised to x sin x cos x. Now we know that sin 2x is 2 sin x and cos x. That this can be applied in this question. So we'll multiply it by 2 and divide it by 2 since it is a constant, so we can take it outside the integral sign. So this I will be equal to half integration of e raised to x, and then 2 sin x cos x we are writing it as sin 2x according to the formula which I just indicated. Now we'll apply isolate. Isolate is what? Inverse, log, algebra, trigonometry and exponential. So trigonometry will take first because it comes first in isolate. So we will call it as u, the first function, and the second function will be e raised to x, which is the exponential function. We are calling it as v. An integration of u and v, u multiplied by v, is already known to u integration of v dx minus integration of, then first the differentiation of u, first function, then the integration of the second function, which is integration of v dx, and then we multiply these two, and finally we will take the integration. So this will be half Okay, half I'm just keeping it for a while. I'll introduce it in a bit. Let's do this one. Sine 2x will come first. Integration of e to the power 2x minus integration of first differentiation of sine 2x and then the integration of e to the power 2x again. So e raised to x again dx, and then we'll integrate it again. Now this will be sine 2x only. E raised to x will be e raised to x, and then we will integrate 2x. 2 will differentiate 2x. 2x will be differentiated and 2 will come. That will be in the denominator. Minus integration of, so differentiation of sine 2x is cos 2x, and then 2x will also be differentiated. It will be 2. So this will be 2 cos 2x, and e raised to x will be e raised to x only. So we have to do it. The e raised to x has e raised to x by 2 we have cancelled. Now this whole is another integration. Because we called it as I, let us call it as I1. So I am integrating this I1 separately, then we will put the result in the required place. So I1 is e raised to x cos 2x. Same thing we are going to apply. U will be cos 2x, V will be e raised to x. This I1 will be, so we have cos 2x, integration of e raised to x dx minus integration of, dx is always there, okay? Even if I leave, you can assume that dx will always be there. And cos 2x is minus sin 2x. So negative, I have made the negative as positive. And it will be 2 sin 2x for cos 2x. E raised to x will be e raised to x by 2. This 2 gets again cancelled. I1 is what? E raised to x by 2. This will be cos 2x plus integration of. So this will come again. This is a reincarnation. Because e raised to x sin 2x has come again from where we started. Alright? And this is not actually I, it's actually 2i. Because if you remember, this half was taken, I didn't use it. So it was taken into some temporary storage. Now I am bringing it back. So this will be, it will be 2i actually. So 2i it will be, and this will be e raised to x divided by 2 cos 2x. And this is I1. Now the first term remains like this, e raised to x sin 2x divided by 2 minus. Now all this needs to be multiplied by negative because we are actually placing it in a place where negative is already there in the beginning. So now I've changed the sign and now I'm placing it e raised to x by 2 cos 2x, and this will be negative 2i. Now this half is already there if you remember. So you have to include this half also. This will be 4, this will be 4, and this will be half. I told you that I made this 2i with the equation from where we started, but half was already there because we actually are doing e raised to x sin 2x. So that's why I multiplied it by 2, and this after multiplication 2 has come in the denominator. We have taken 2i here, e raised to x sin 2x minus e raised x cos 2x. Now this 4 is there, so you can just take 4 common. Now I minus I plus I it has become. Now you can take e raised to x common from here. 2 is already there. So you can bring this 2 in the denominator, it will become 8. So you can take 8 common, e raised to x common. Whatever is inside sin 2x minus cos 2x will remain inside. So this will be I. This is plus constant of integration. That is your final result. Now how to do this? So whatever I have explained, this is the way you are going to go about it. And all this English like languages is very important because you are actually making it understand to other person. E raised to x sin x dx. So we'll again apply the isolate here. So in this isolate, sin x will come first function and e raised to x will come as the second function. So this integration will be integration of e raised to x sin x we are doing. So first of all sin x will come in front. Integration of e raised to x minus integration first differentiation of sin x, then the integration of e raised to x, again integration and final integration. So we'll again integrate it again after multiplying. E raised to x will be e raised to x by 2. This will be sin x minus integration d by dx of sin x is cos x. E raised to x will be e raised to x divided by 2. Now we have to integrate it again. This whole has to be integrated again. So let me write it again because we will be dealing the other part differently, means separately. So half I am bringing outside. It will remain as e raised to x cos x. But this is I. Now this is going to be I1. And I will do it separately. So let me do this. I1 will be equal to e raised to x cos x. Again isolate, same thing we are going to do. So cos x, integration of e raised to x minus integration of d by dx of cos x, and then again e raised to x dx. So just u into v integration I am applying. Cos x, e raised to x will be e raised to x by 2 minus d by dx of cos x is negative sin x. So minus minus become plus, so it will be sin x inside the integration sign. E raised to x will be e raised to x by 2. So this I1 has become like this, e raised to x cos x by 2 plus half we are taking outside again. So it will be e raised to x sin x. Now from where we have started? From e raised to x sin x only. You can just write or replace this e raised to x sin x by I. So I am writing the unchanged content, and then here I am placing I in place of e raised to x sin x. And since we have a negative half in front, so we need to multiply this negative half before actually putting it in the original equation. Just multiply negative half, again multiply negative half, so it will be 1 by 4. Okay, now we don't have to deal with negative half. We just have to replace it after e raised to x by 2 into sin x. After this we have to place all these content which we have just completed as per I1. So e raised to x cos x by 4, this is negative 1 by 4 I. So you can write it as I by 4. Now this I by 4 can be taken on left. This will be I plus I by 4. So I plus I by 4 will give you what? It will be 5 by 4. 1 plus 1 by 4 will give you 5 by 4. So on the left it's 5 by 4 I. On the right it will be, because I by 4 we have already taken. So you can take this e raised to x common first, and the highest number is what? 4. So e raised to x by 4 you can take common. So the second part will remain like this, cos x only. But from here, when we have taken this outside, it will be 2, you have to multiply it by 2. So 2 sin x minus cos x will be there. Now you can just cancel this 4 in the denominator and bring this 5 in the denominator. So I will be equals to e raised to x by 5, because 5 has come downstairs on the right hand side. So e raised to x by 5, then 2 sin x minus cos x, and plus a constant of integration. This is your final result. Now how to do this in a formal way? So this is the formal solution which I am presenting you. You can follow this scheme, or you can follow what I have told you or what I have indicated. But you understood the logic, right? Now I will again apply isolate here. This is e raised to x sin ax plus b form. So just call this as first function sin 3x plus 1. E raised to x will be the second function. So this I will be equal to, first function is like this, sin 3x plus 1. It remains unchanged. Then so integration of e raised to x dx minus now differentiation of sin 3x plus 1, integration of e raised to x dx. Then all of this being done, then we have to integrate it again. So e raised to x will be e raised to x divided by 2. Sin 3x plus 1 will be sin 3x plus 1 only, because we haven't changed it, minus differentiation of sin will be cos. So cos 3x plus 1 will come. And then we have to differentiate 3x plus 1 also. So 3 will come. Let me differentiate it separately just to make you understand. Cos 3x plus 1, then 3x plus 1 again has to be integrated. That will give you 3. E raised to x will be e raised to x divided by 2. Then we have to integrate this. Now what do you see here? E raised to x divided by 2. We have sin 3x plus 1 minus. Now 3 and 2 you can bring it outside, because you can bring it outside the integration side. So we have e raised to x, then we have cos 3x plus 1, and then behind we have a dx. From here to here, let's call it as I1, and we'll do the I1 separately. I1 is equal to, same thing we have to do. So we'll again apply the isolate. So e raised to x cos 3x has to be integrated here. 3x plus 1. First function is cos 3x plus 1. So first function will come first. Then the integration of e raised to x minus integration of d by dx of cos 3x plus 1, then integration of e raised to x again, and then this whole will be integrated again. The result will be, so I have I1, this I1 will be equal to cos 3x plus 1, e raised to x will be e raised to x divided by 2, minus integration of differentiation of cos 3x plus 1 will be what? So, minus sign. So minus I have made as positive now. Sin 3x plus 1, then 3x plus 1 differentiation will give you 3. Now the integration of e raised to x will be simply e raised to x by 2. This will be e raised to x by 2. So this I1 has become something like this, e raised to x by 2 cos 3x plus 1. Now 3 and 2 we can again bring outside. 1 3 by 2 was already there in I. Now I1 has given us again 1 3 by 2. This sign is actually I'm changing just to make it a streamline. So e raised 2x sine 3x plus 1 dx. Now this is I only. It has taken one more birth. So this e raised 2x by 2 cos 3x plus 1 minus 3 by 2, and this whole is I after that. Now there is see, I've just changed the sign because there was a confusion in sign. So I just changed the sign, right? So now we need to multiply it by negative 3 by 2. So multiplying everything by negative 3 by 2 and changing it accordingly. The last term will become 3 by 2, 3 by 2, that will be negative 9 by 4 I. Now just place it here. This I will be equal to e raised 2x by 2 sine 3x plus 1 and negative 3 by 4 e raised 2x after multiplication of negative 3 by 2. Okay. So e raised 2x cos 3x plus 1, and then after that we have negative 9 by 4 I. So this negative 9 by 4 I will be taken on the left. So it will be I plus 9 by 4 I, and that will give you 4 plus 9 by 4, that will be 13 by 4. So 13 by 4 I is equal to, now what you can do here is, you know that e raised 2x can be taken as common, and 4 is the highest in the denominator, so you can take that common also. So e raised 2x divided by 4, inside this we have sine, okay, when we take this the right part, only 3 will remain. So negative 3 cos 3x plus 1 will come. On the right, since 2 is in the denominator, so you have to multiply it by 2. So 2 e raised 2x already taken out, so only sine 3x plus 1 will remain. Now this 4 can be cancelled in the denominator. 13 you can bring downstairs. So the final I will be something like this, e raised 2x by 13, and then we have 2 sine 3x plus 1 minus 3 cos 3x plus 1, and finally a constant of integration. That's your final answer. Now how this will be done? This is a complete solution because there was a glitch in negative sign which I told you. So you can just have a reference from here. Now e raised x sine square x. Now it will be possible that you can use sine square x directly, but a better idea is that 2 sine square x is equal to 1 minus cos 2x divided by 2. Sine square x is this one, 1 minus cos 2x divided by 2. So sine square x can be written as 1 minus cos 2x by 2. 2 cos per x is 1 plus cos 2x, as you remember. So this I can be written like this, integration of e raised x 1 minus cos 2x divided by 2, and then this with a dx. Now we will multiply this e raised x inside, and 2 is already there. So integration of e raised x by 2, and first term is e raised x by 2, second term will be e raised x into cos 2x by 2. So e raised x cos 2x, this half you can bring in front. This is your I. Now this is I1. We'll call it as I1, e raised cos 2x. So this I1 will be equal to, we'll apply the isolate again. This will be cos 2x integration of e raised x minus integration of d by dx of cos 2x integration of e raised x, and 2 integration will be done here. So e raised x will be e raised x only. This will be cos 2x minus integration of cos 2x is negative sine 2x. So sine 2x negative, I have made it as positive. So you have 2 sine 2x e raised x. Now e raised x cos 2x plus 2 integration, now e raised x sine 2x. Now I am taking it as I1, but since e raised x sine 2x has come up again, so we have to take it in a other way, or you can solve it here only. I am just, for the sake of explaining, I am taking it differently, means in a separate way. I2 is sine 2x e raised x. So sine 2x you can take first, integration of e raised x minus integration of d by dx sine 2x, and then integration of e raised x. So this is e raised x only, sine 2x minus differentiation of sine 2x will be cos 2x, 2 will also come, e raised x will be e raised x only, along with the dx. Okay, I am missing dx sometime, but don't worry about that. E raised x sine 2x, 2 we can take outside. When you take 2 outside, what do you see? From where we started, it's I1 only. E raised x cos 2x is I1 only, so it will be negative 2 I1. So I2 is consisting of I1, and I2 is actually coming from where? From I1. So this I1 I am writing now, and I am replacing I2 here. So just multiply with 2 and write everything. Multiply 2 with I2 and place it in I1. So e raised x cos 2x plus 2 into I2 will give you 2 into e raised x 2x minus 4i 1. Now this I1 you can bring on the left hand side. So just bring it here, I1. So I1 minus 4I1 will become I1 when we bring it on the left hand side, I1 plus 4I1. So it will be 5I1. So 5I1 is equal to, you can take e raised x common. If you want, you can take e raised x common, but you can use it later also. So 1 by 5 will come here because we have to replace I1 in I here. So this will be e raised x by 2 minus half. Inside this, just put this I1. So 1 by 5 e raised x cos 2x plus twice of e raised x sin 2x. And just multiply these with half. Half is already there outside. So it will be 1 by 10 because 1 by 5 was already outside. So 1 by 10 you can just write. So e raised x you can take common. It will be cos 2x plus 2 sin. It's all sin 2x, okay? There is slight change I am doing. Everywhere where I have written sin x, just update it as sin 2x. Now this will be, I will be e raised x you can take outside divided by 2 minus e raised x by 10. So it will be cos 2x plus 2 sin 2x plus constant of integration. So this is how it has to be done. This is a reference in front of you, okay? And I have broken it in number of parts, but you can do it like that. Now in this question, 1 by x cube sine log x. So there are three functions here. First is 1 by x cube, then we have a sine function, and then the log. So we have algebraic, logarithmic, and sine function, that is trigonometric function. So we'll take this log x which is inside the sine and we'll place log x equals to t. You already know that base is e, so in the previous discussion also I have explained this is equal to e raised t equals to x. So this x equals to e raised t. So we are going to use this one and this one in the later part, and let's differentiate both the sides. So dx by dt will be equal to e raised t because we are differentiating with respect to t. So we are doing d by dt of e raised t, that will come as e raised t only. So dx will be e raised t dt. So when we are taking log x as something, says t, then we have to talk about dx also. And dx also has come as e raised t dt. So this integration will be formed like this. 1 by x cube. Now x is e raised t. So x cube will be e raised 3t. So e to the power 3t it is. Now what is the benefit? You might be asking why t equals to log x you have put in. You'll see 1 by e raised 3t sine. Now log x you can write just t. And in place of dx we are going to write e raised t dt. So I'm replacing this 3 here now. E raised t dt. So e raised t is there. E raised 3t is in the denominator. When it goes up, e raised negative 3t and e raised t, the power will get added. T minus 3t is negative 2t. So this whole will be e raised negative 2t. This integration will be e raised negative 2t. This and this one has combined and e raised negative 2. And of course sin t is already there. Now we'll integrate this. Now we can apply the ILATE, integral, log, algebra, trigonometric and exponential. Which one comes first will be the first function. So sine function will get the first position and e raised negative 2t, which is the exponential function, will be the second function. So integration of u into v dx, this is the formula I am using, and I am quite aware that you are aware of this solution or the expansion of this integration u dot v. So sin t comes outside, e raised negative 2t inside, that minus differentiation of sin t and then integration of e raised negative 2t dt. And then again integration will be done. So this is sin t. E raised negative 2t will be e raised negative 2t only. Then we have to differentiate negative 2t, negative 2 will come and that has to be kept in the denominator. So negative 2 will come in the denominator minus integration. Now e raised negative 2t by 2, negative 2 will come from here and sin t will be cos t. And again integration will be done. So we'll do what negative 2 will bring in front. Why? Because we just need cos t e raised negative 2t inside. So when you take this negative 2 inside, this plus half will come outside. So let's call this initial one as I, and let's call this one e raised negative 2t cos t as I1. So we'll do it separately. This I e raised negative 2t cos t, we are calling it as I1. So there will be a reincarnation. What I am saying is this will come again. You will see e raised negative 2t sin t will again come. और e raised negative 2t cos t will again come. That is going to be in the future just now. So let's call it as some I1 or some other I2, and I'm integrating it the way we have just completed the previous one. So I'm applying u dot v here. So same thing here. So this will give you, so I'm cos t, and this e raised negative 2t will be e raised negative 2t by 2, e raised negative 2t by 2 here. Cos t will be negative sin t. So sin t here, negative goes outside, it will be plus. So negative, negative, plus, and you don't have to take negative outside or make it as plus, because negative, negative can be cancelled here only. So you can just write e raised negative 2t by cos t divided by negative 2, and half I am bringing outside, the sign will not be changed. E raised negative 2t sin t. Now you tell me, what is this? This is what? This is the initial one from where we started. So this is actually the fourth equation, if you call it 4. So we'll just write I here. Now I am changing now, because this is I1 actually. So I am going to place I1 in place of this expression. So I will be equal to, this is e negative 2t sin t divided by minus 2 plus half, and in place of cos t e raised negative 2t, I am going to write everything which we got for I1. So this e raised negative 2t cos t by minus 2 minus half, and here only you have to write I. Now you can take, first you have to multiply half inside, then we'll deal with the other thing. So e raised negative 2t sin t negative 2t, this doesn't change. Here we have half and negative 2 will be negative 1 by 4, e negative 2t cos t. Now when we multiply half with negative half, it will be negative 1 by 4, and this will be I. Negative 1 by 4 I will be taken on the left. So we'll combine this I and 1 by 4 I, and this will give you 5 by 4 I. 1 plus 1 by 4 is 5 by 4. So 5 by 4 I will be equal to, now we can take something common here. E raised negative 2t is already outside, so you can take common. Now you have minus minus, both terms are negative, so you can take a negative outside. You can take a 4 in the denominator. When you take this, so this everything will be plus inside now, because negative is already taken. So e raised negative 2t divided by 4. Since 2 is in the denominator, you have to multiply it by 2. So the first term will be multiplied by 2. So 2 sin t will be there. And this will be, 4 is already taken. E raised 2t is negative 2t is already taken. So you have cos t inside. So there is a little space left for us, but I will cancel this 4 here. Bring this 5 downstairs on the right hand side. So e raised negative 2. So what is e raised negative 2t? See, e raised t was what? If you remember, e raised t was, this is e raised negative 2t. E raised t was what? X. And if you just take the power negative 2 will come here also. It will be x to the power minus 2. So 1 by x square it is. So in place of e raised negative 2t, you can write just 1 by x square. This is 2 sine. What is t here? Log x. I told you I'll use that thing. So log x here. Plus cos. Inside this we'll use log x. Cos log x. And now I will finish it off with the constant of integration. So this is your final result. Now let's see that this is how we are going to solve it. This is the reference for you. You can follow this reference. There are certain intricacies which I discussed with you, but the way you write is something like this. E raised to x, cos square x and dx. Now sin square x you already know. We have already done that question. You know that 2 sin square x is 1 minus cos 2x. 2 cos square x is 1 plus cos 2x. So cos square x will be equal to 1 plus cos 2x divided by 2. So in place of cos square x, we'll replace this. So integration of e raised to x, this is half. So I'm taking this half outside. So e raised to x and 1 plus cos 2x. So we can deal this half later or maybe here also. But we'll see. E raised to x, let's multiply this inside. So first term will be e raised to x only. And the second term e raised to x dx, and the second term will be e raised to x into cos 2x. There are two different terms we got. So e raised to x integration will be e raised to x only. then 2x will be differentiated, 2 will come, that will go in downstairs. So this half you can multiply here. So let's multiply half here itself. So e raised 2x by 4 plus 1 by 2 e raised 2x cos 2x dx. Now let's call it as I1. So we'll do this I1 separately and then we will replace it. So I1 becomes e raised 2x cos 2x dx. So those who have already done this, they can just go to the next one, because this is e raised 2x cos 2x e raised 2x sin x we have already done. So the integration will be integration of u dot v. I am taking cos 2x as the first function. So this is the u dot v integration. So this will come. This is how we elaborate or apply the formula. So cos 2x e raised 2x will be e raised 2x divided by 2 minus d by dx of cos 2x. Cos is minus. So minus I am bringing outside. So sin 2x, 2 will also come. E raised 2x by 2 this will be. This is dx. So 2 you can cancel. Now sin 2x into e raised 2x, I am calling it as I2. So if you see the solution or reference, you will not see these I1, I2, all these etc. But since I want to explain you, I am taking this separately. So I2 is integration of e raised 2x and sin 2x. So it's an altogether different integration. So sin 2x will come first. Again, integration of uv. U I am taking as sin 2x, v I am taking as e raised 2x, and you know how this go about. So we have e raised. This is how we open it up. So this will be sin 2x, e raised 2x will be e raised 2x by 2, and then we have minus sin 2x is cos 2x, and 2 will come in front because we are differentiating. This is e raised 2x by 2 dx. 2 gets cancelled. Now what do you see here? This is actually I1. I told you e raised 2x cos 2x dx. I am assuming it to be I1, and it is actually I1 only which is coming again. So e raised 2x by 2 sin 2x minus I1 is actually equal to I2. Now this I2 has to go there. I'm just trying to divide and conquer. So I'm bringing this I2 here. And this whole has to be placed in place of I1. So let's write I1 first. I1 will be equal to cos 2x. E raised 2x by 2 and cos 2x you can write. Cos 2x. And in place of all of this, you will write this I2, which is e raised 2x by 2 sin 2x minus I1. And this I1 you can bring on the left. So it will be twice of I1. So you can just take this here, cancel this I1. 2 will be coming on the right downstairs. Now put this I1 in the original one. So e raised 2x by 4 plus, now you have to multiply this with half. Because this is I1, but half is already there. So 1 by 2 into 1 by 2 is 1 by 4. So e raised 2x by 2 cos 2x plus e raised 2x by 2 sin 2x. Now e raised 2x by 4 will remain like that. But in the second part, you can just do something, like you can take something common. So e raised 2x by 4 it is plus. Now you can take e raised 2x outside if you want. But first multiply. Let's multiply first. So when you multiply this 4 in the denominator, it is 4 to the 8, 4 to the 8. So 8 comes in the denominator of both the terms. So this 8 you see plus constant of integration. Now you can do one more simple thing which is not required actually, but e raised 2x by 4 plus 8. Now you can take e raised 2x common and 8 common because it is common in both the terms. So e raised 2x divided by 8, it will give you sin 2x plus cos 2x plus constant of integration. This is your I. Okay, this is your final answer. So this is the way you are going to go about it. And there are I1, I2, I took, but I hope you will be able to do this. E raised negative 2x sin x. So e raised 2x sin x, e raised 2x cos x, e raised negative 2x sin 2x, e raised negative 2x cos x, cos 2x. All these sort of questions we have done. And you already know this, how to do this. So let me show you the reference. If you have any problem, just let me know in the comments and I'm going to solve this again. But if you're following me, then you already know how this question is done. Now you have x square, e raised x cube and cos x cube. So there are three different terms there, but there is something which is common here, which is x cube, because differentiation of x cube can give you x square also. Now let's take this. Okay, let's take x cube as t. So dt by dx equals to 3x square. So dt will be equal to 3x square, dt by 3 you can bring in x square dx. So x square dx we got. So this I will be equal to, in place of x square dx, just write dt 1 by 3 can be brought out. Ex cube, so e raise t, cos x cube is cos t. Now do you see? E raise x, cos x, e raise x, sin x was the first thing I told you in the beginning of this discussion. So there is just a revision of e raise x, cos x which we are going to apply here. So we'll apply the isolate here. So this is 1 by 3. We'll talk about this 1 by 3 later. But e raise t cos t is the first function and e raise t is the second function. So I'm applying this u dot v integration, and you know already how to do that. So we have this expansion of that formula. Cos t, then e raise t minus d by dx of cos t is negative sin t, so I have brought negative outside, and then e raise t dt. Now we are doing it separately because this is going to come again, you already know that. So we call it as I1. In sin t, e raise t, I am applying this uv integration again. So you all are already aware of that, so let's do this. I1 and is having two functions. First function we are taking sin t. Second function we are taking e raise t. So this application of this formula we are applying d by dt of sin t, again integration of e raise t dt, this whole. So we have e raise t sin t minus d by dt of sin t is cos t, e raise t is e raise t only dt. So you don't have to integrate this because this is the original one. If you remember, if you make 3i, then it is actually equal to integration of e raise t cos t only. So e raise t sin t minus, so e raise t cos t is simply 3i. So now I am writing 3i here and I is on the left. Now let's transfer this in I. So this I will be equal to 1 by 3 was already there, cos t e raise t. So let's write it like that only, cos t e raise t. In place of this I am writing I1 now, e raise t sin t minus 3i. So we need to multiply this 3 inside first. So this I will be equal to, it will be 1 by 3 e raise t I am taking outside, and I'll just take 1 by 3 and e raise t outside. So it's better because cos t plus sin t will remain inside. When we multiply 1 by 3 with 3i, it will be I only. Now this I goes on the left. I minus I on the right will become 2i, I plus I. It will be e raise t by 3 cos t plus sin t. Now just take this t equals to x cube. So bring this 2 in the denominator. I will be equal to e raise t will be x cube, and then 3 2s are 6. Then we have cos x cube because I am replacing t by x cube now, plus sin x cube plus a constant of integration. That is your final answer. So this is how it will be done. It's a very simple question because this kind of question we have done previously also, but you need to write it in the way I am presenting. So this is all about this exercise. Thank you so much. Have a good one.